Hello there, we're going to talk about the simulation and the thickness with the reference layer data. The reference layer, make it as below. This is a reference wafer. We make a wafer and we make different material layers on the wafer to be the reference layer wafer. For example, we have many patterns made by many kind of material to be a layer, to be a thin film. You can see this is the thin film. And this pattern, we make it as, for example, an oxide layer, or we can call it oxide thin film here on the silicon pure with the desired thickness. So with this pattern, we have the oxide layer on a pure silicon with desired thickness. And this pattern, for example, is a polycide layer on a pure silicon with a desired thickness. For example, this pattern, this is the metal layer on a poly layer on a silicon with desired thickness every layers. And this we make a silicon nitride layer with desired thickness and so on. So we make these patterns on this reference layer with many kind of semiconductor industrial layer, and the thickness designed to be very often useful for semiconductor industrial. So the material to be a layer, and the thickness to design just for the semiconductor industrial usage. And this is the reference wafer structure. And how we use it? We use it to measure and get result with reference wafer. We use the optics measure thickness equipment to measure this wafer and get the result. Because we know the thickness of the reference wafer with all kinds of material. We know the material and we know the thickness. So we know the correct result. And this correct result for calibration for the equipment measure. And for the SPC control, we measure it to confirm the equipment is okay, and measure data use the SPC to control this equipment. And if found that the equipment measure result is different from the reference wafer measure result, we can set the offset value for the equipment to let the equipment measure result to be correct. And after the PN and the service with the equipment, we use the reference layer wafer to test, to check the equipment is back to be ready for measure correctly. So this reference wafer usually made by major equipment manufacturer. So if we buy a optic thickness major equipment, we ask for the manufacturer to provide this standard reference wafer for us to confirm the correct capability of the equipment. The reference wafer notice as below. This is a reference wafer, and usually we put it in a space with fixed temperature as manufacturer suggestions, and fixed humidity as suggestion by the manufacturer, and a fixed nitrogen fill enough to avoid the surface of the reference wafer get polluted, just like oxide layer grows on it. And also have the fixed lifetime. About the lifetime of the reference wafer. This lifetime made according to manufacturer's design. Because every time pass, it will grow an oxide layer on the surface of the reference wafer, and more particle and more other pollutions on it, so according by the manufacturer design. And if we use the reference wafer to measure and compare or simulation and fit this with the major result of our major equipment, the offset value shift over limit. This means that the reference wafer result shift too much after inspecting our equipment, and the equipment is not out of order. Then we consider to renew the reference wafer for it, and the lifetime is end due to monitor value out limit. We use the reference wafer to do the usual inspection with our SPC control. If the monitor value out of order and out of spec, out limit of the SPC too much, we consider to renew the reference wafer. So we use the reference wafer to do the simulation and the fitness database to calibrate our equipment, even to form the final result of the equipment. Okay, let's all see you next time.